Hi class. Previously we've looked at sun angles and solar intensities and the importance of those two factors in determining how much solar radiation reaches the Earth's surface to warm up the Earth's surface. Now we're going to backtrack a little bit and look at how does solar radiation actually reach the Earth. Okay, and as it indicates here, it reaches Earth in wave form because that's how radiation travels. So I want to give you a little bit of background on radiation and how it travels in wave form. So let's use this as an example. So I'm going to try to draw this very carefully. All right, it's not too careful. Oh well. So when we're looking at radiation traveling in wave form, it is described by wavelength. And the wavelength is the distance between successive crests, or we can look at successive troughs too. And so this distance here is one wavelength. Okay. And so that's one, or we could look at the successive wave troughs, and that would also be one wavelength. It'd be the same distance. Okay. Now, along with the wavelength, there's a concept called frequency, and frequency is how many waves pass a given point in 1 second. Okay. So frequency equals, so let's say that this segment right here travels this distance, this much of a segment travels a given point in 1 second. Okay, so that would be 1, 2, 3 waves per second. Okay, or oftentimes we refer to that as 3 cycles per second. Okay. Now let's take a look at another form of radiation. Okay, and this one has a different form because it's going to have a different wavelength. And so I'm going to very purposely draw it. Okay, so here we have another type of radiation. You'll notice it looks different because its wavelength is much shorter. So again, wavelength will be the distance between successive crests or troughs. Okay, so here's one wavelength. Okay, it obviously looks different. The green looks different than the blue. Okay, so if we take a look at the frequency of the quote-unquote green radiation here, we can count, and so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the frequency here is 10 waves. Again, we determine that because this segment here is what passes a given point in 1 second. And so this segment is made up of 10 waves. So 10 waves per second. Okay, or again, if we use cycles, 10 cycles per second. Okay, so we see a relationship building up here. Okay, so that you'll notice that the blue radiation has a longer wavelength, the green radiation has a shorter wavelength. Okay, so radiation that has a longer wavelength also has a lower frequency. So the longer the wavelength, the lower the frequency. And the importance of that is that the lower the frequency, the lower the energy content of that form of radiation. Lower energy, am I going to run out of room? Content. So a longer wavelength results in a lower frequency, and a lower frequency means that radiation has a lower energy content. Okay, so let's turn that around then. Let's take a look at the green radiation. The green radiation has a shorter wavelength. And a shorter wavelength will translate into a higher frequency. So this one had a frequency of 10 cycles per second. Okay, so a shorter wavelength translates to a higher frequency. And a higher frequency means that this energy has, or this radiation, sorry, has a higher energy content. Okay, so we find that in nature, and especially what we get from the sun, that the shorter the wavelength, the higher the frequency, the higher the energy content. The longer the wavelength, the lower the frequency and the lower the energy content. So the energy that we get from the sun, the shorter wavelengths would include gamma radiation, X-ray radiation, ultraviolet radiation. They have shorter wavelengths, so they have a higher frequency and higher energy content. So you really have to be careful when you're dealing with these forms of radiation that have a shorter wavelength. And just a quick example, if you go to the dentist's office and they give you dental x-rays, that's a form of radiation that has a shorter wavelength. So you'll notice that the hygienist never stays in the room with you. She or he puts a lead apron on you. All this is to protect you because those x-rays have a very high energy content. Okay? Conversely, if you look at microwaves and radio waves in particular, you never see anybody worried about radio waves. We got radio waves all around us being put out by radio stations. And so those, we don't worry about radio waves because radio waves have the longest wavelengths of any form of radiation. So they have a really low frequency and therefore a really low energy content. And so you never have to worry about radio waves passing through a room or anything. So hopefully that makes sense to you. And if you've got questions, always make sure you let me know.